Hello. Today we are going to use the data about uh, annual average temperature by country and the GDP per capita by country. And uh, I will show you how to make this like scatter plot and how to make a trend line first. And then I'll show you how to calculate the covariance and correlation coefficient on Excel. So let's look at the Excel file. Right, let's first look at this. Like this is average yearly temperature, and this is GDP per capita. There are country names like Mongolia, Russia, Canada, Norway, like that, and there are total 183 countries. Okay, so you can see those countries. And to make a scatter plot, it's pretty simple. Just choose these two columns and click Insert. And here, this is scatter plot, right? So pretty simple, right? Choosing this will already give you the scatter plot like this. Okay, so you may edit the like say color and different things by clicking here, right? So for example, if you click here, you can change color to red, something like this. So you can decorate the graph as you want, something like this, like a line, doesn't do a line. So then, additionally, if you wanted to make a trend line, it's also pretty simple. Click here, click the plus sign, and I will add trend line. So there are some options. Linear, like we are going to use linear forecast. Then this is the added line. So if you remove that, that goes away. And then if you click it, you will see those this trend line. Also, you can change the color as you want, like say red, like green. So this is how we make a scatter plot on Excel, which is pretty simple. Okay, next, then I am going to show you how to calculate the covariance. We have formula for that, so you can insert formula about covariance. If you search covariance, you will see uh, three different formulas, but the last one is obsolete. So basically, there are two formulas, covariance.p or covariance.s. So .p means population formula, which means the denominator is n, and .s means covariance sample covariance formula, which means the denominator is n minus 1. So either way is okay, but usually the sample covariance is more common. So you may click covariance.s and array1. This is the first variable. I will include this. The column B from 2 to 184, and this will include from here to here, column C. And then if you click OK, you will see this is the covariance. The covariance is minus 66,000, right? So, but as I said, remember, this is covariance, sample covariance. This does not mean any, like, first, what you can see here is the covariance is negative. So the temperature and the GDP per capita are negatively correlated. However, the 66,000, the magnitude, the absolute value, doesn't mean anything. It does not have any meaning. It just tells you that GDP per capita is a huge number. There are many zeros. Now let's compare this to population covariance. Population covariance, you can just type equality covariance.p and choose this and choose this, right? Close the parenthesis. Then you will see similar but slightly different value. It is population covariance is minus 65,000 and about 900. So that's because the denominator is n, for the population covariance. So denominator is n, but sample covariance has denominator equals n minus 1. Now then, let's think about correlation coefficient. To use the correlation coefficient, let's go to Formulas tab and insert function. You can type correlation coefficient. Then you will see three things, but I will use the first one, correlation, correl, C-O-R-R-E-L. This is the formula we want. Same thing, we are going to choose the first variable, and in the array 2, we choose the second variable and click OK. Then this is correlation coefficient. Correlation coefficient is minus 0.31. So the sign does not change. Sign must be the same as the covariance, but the scale is reduced, standardized between minus and plus minus 1. So that's the correlation coefficient. And remember, we get this correlation coefficient by standardizing the covariances using the standard deviations. So remember, standard deviation has also two different formula, standard deviation .p or .s, right? Standard deviation STDEV.p is for population standard deviation, and .s is sample standard deviation formula. Let's use .s. Let's calculate the standard deviation for the temperature, which is 14 degrees Fahrenheit. And by click and drag this, you will calculate the standard deviation for GDP per capita, right? The GDP per capita is calculated like this. Now let's see. What we are going to try is we are going to directly calculate the covariance divided by two standard deviations, right? Then you will get the same number as the correlation coefficient, right? Of course, that's how the correlation coefficient is calculated. But what you have to think about is we are using the sample standard deviation and sample covariance. You have to match the formulas. For example, if you use population standard deviation, then the population standard deviation is slightly different from the sample standard deviation, right? So these are the population standard deviations, and recalculate the correlation coefficient using population covariance divided by two population standard deviations. Then it will be also the same correlation coefficient. So as long as you match the sample covariance with sample standard deviations, or population covariance with population standard deviations, the correlation coefficients are the same, right? So correlation coefficients do not distinguish sample or population formulas. It is always the same, but the covariance and standard deviations can be different depending on the formula you are using. We learned that in chapter 4. Okay, so this is one thing. Also, what I'm going to show you here is, look at this. The data, the temperature is measured in Fahrenheit, and the GDP per capita is measured in dollars, right? 2005 dollars. I am going to change the units. So I'm changing the tabs, right? So here, the new tab has temperature in Celsius, measured in Celsius, and the GDP per capita are the same, right? I only change it the units of the temperature, and let's see what happens. Covariance, I will calculate covariance.p for this guy and for with this guy between these two variables. Correlation coefficient is now minus 36,000, right? Right. So the sign is the same, but the magnitudes are very different. Previously, when the temperature was in Fahrenheit, the covariance was minus 66,000, but it is now 36. Let's try covariance.s. Then we will choose same thing, and the covariance is slightly different from the population covariance, but the sample covariance is also similar, minus 36 something, 36,000 something. So that's because the scale is very much different from the earlier example, because Fahrenheit and Celsius have different scales. However, if you calculate correlation coefficient, you may expect the scale does not matter because it is standardized between 0 and 1. So the correlation coefficient is minus 0.31033, which is the same number as before, right? As they should be. So this is why we are studying the correlation coefficient. It does not depend on change of the units, so which is more kind of easier to understand. Okay, so in the next video, I will show you how to handle multiple variables on Excel. Okay, thank you for watching. See you later.